All right, a good Tuesday afternoon to you. Meteorologist Brian McClure. Today I decided to wear my Lightning jersey. I have no clue if it's going to be any more luck tonight. If it's not, Lightning might be in trouble. And for all the Boston fans out there, they're probably ecstatic with the first game. But the Lightning fans, whew, that was rough. So hopefully the second one will be better. All right, how about we get to the tropics and talk about Laura? There it is. It's centered north of the Yucatan Peninsula, northwest of Cuba, and essentially now out over the middle of the Gulf where, yes, it can strengthen. Hurricane Hunter aircraft flew through it this morning. They're flying through it again right now, actually. And they found pretty much what we expected. It was stronger, so therefore it got declared a hurricane. That's not a surprise. Now it's more just a matter of how strong. And remember, we've been talking about this since last week, so this shouldn't be a big new surprise to anybody that's been watching any of these videos. We knew the Gulf of Mexico is when it would finally get away from wind shear, when it would finally get away from land, when it would finally get out in the middle of the open waters over warm water and be allowed to strengthen. If you look at these wind colors, you don't have to stress or know too much about this. Don't worry about this as far as colors. Just know that where you see these reds and purples over here, this is where the stronger winds are, okay? So essentially what you're looking at is, yet again, the storm's a bit lopsided with all the strong winds on the east-northeastern side. And remember what I said yesterday. You would start to see a stronger hurricane, more developed, more symmetrical when these stronger winds came all the way around like that. And that has not happened yet. So is it better, more organized? Absolutely. But is it strong yet? No, not really. Think of it more like it's a storm with some strong winds on the northeast side displaced from the center, but it's not what I would call a classic big hurricane yet. The reason why all the forecasts call for the strengthening right out here in the middle and western Gulf of Mexico is because it gets away from wind shear, it stays over warm water, it stays in an environment where it can rapidly intensify. Will it? It's not a guarantee, but it's always better to err on the safe side, especially when you're talking about a potential hurricane headed for a landmass, and especially in this regard, a very heavily populated landmass, possibly anywhere between Houston, Galveston, Beaumont, and Lake Charles, Louisiana, essentially in those areas, which is what we've been saying right along the Louisiana-Texas border. The latest guidance has shifted a little bit to the west over the past 24, 48 hours. Actually, I should say over the past 5 days. If you think about it, technically it's continued to shift west because remember, we were talking East Florida, then Southeast Florida, then Southern Florida, then the Southern Islands, and it just keeps bumping west. So I guess technically you could say during its entire lifespan, it's been kind of shifting a little bit further west. When you look at the center of circulation, it's right in here. And again, notice how there's still a lot of cloud cover being shredded off to the south. The reason for that is there's still a little bit of wind shear hanging on back here, whereas there is no wind shear out here. So again, we're assuming that as it starts to head in that northwestern fashion, it will get into a better area where it will likely strengthen. As far as water temperatures go, I have heard a lot of people tell me, but the water temperature is just the warmest it's ever been. No, it's the same as what it is most summers. Maybe in a few spots it's a little bit above average, but believe it or not, where Marco just went right through here, the water temperatures are now below average, which is normal. That's what tropical systems do. They naturally are cooling processes. They take warm, humid air masses from tropical regions and they disperse them into cooler continental air masses farther north. It's just kind of like the Earth's way of operating in an equilibrium and a balance. So every time we say, man, I don't want this hurricane to come, I'm in agreement. Trust me, I hate hurricanes headed for any human beings in any land. But at the same time, we also have to understand the hurricanes were here way before we were. So we built in the tropical areas and the coastal areas, and although it sucks when they hit us, the fact of the matter is the hurricanes are Earth's natural process to heat and balance and cool and everything else to just kind of keep things in equilibrium. But yeah, I show you this because you might not know this. There's a loop current on the Gulf Stream, warm body of water that comes up like this. And of course, the Gulf Stream heads through like this. But there's also these little loops or eddies that come off of it. And occasionally when they come off of it, you can get these really warm slugs of water out in the middle of the Gulf. Well, I'm not seeing that right now, at least not where the storm is going. There's one to the south, there's one out here to the east, but this is actually a little bit below average, so that's okay. So I guess my point here is, believe it or not, I'm not seeing extremely hot temperatures. I mean, the water temperatures are always in the 80s in the Gulf of Mexico, so that's not a big surprise right now. Believe it or not, it's a lot warmer down in the Western Caribbean. If this storm had stayed down there, it had a lot more what we call heat potential, warm water to a much deeper depth. Anyways, we'll see how this goes. As of right now, what I'm seeing, the latest trend on satellite, is the outflow is looking pretty good in most quadrants. Again, it's a little squashed back here, and a lot of the rain is being still dispersed to the south, but it's starting to look a little better. By the way, this is that little swirl left over with marker right out here. That's that little silly swirl. So there's nothing left of it other than a little cloud in the sky, but that just goes to show you how sometimes you get those little swirls to linger. I want you to notice something. This is kind of interesting. I'm going to outline here. Let me change my color here to this. Okay, what I want you to notice is right down in here. Okay, you see Florida is located right there. Here is your storm right in here. What I want you to notice is this is where a high pressure is. This is the same high pressure that I talked about yesterday that I said would keep, and actually didn't talk about it just yesterday. I have talked about it for a week. I said would keep it south of Florida, would keep it moving westward. But what I want you to notice today, I'm going to go back and forth. And I want you to notice how this high pressure seems to be exerting a lot of pressure on the storm moving in this direction. And then there's a dip in the jet stream, a cold front that comes down up here in the mid-Atlantic. And that starts to exert pressure on the back side of the high. When that happens, sometimes what you'll get is a little kick of the high, kind of kicking out of the way from that front. And I think that might be what we're looking at, because watch. It's subtle, but you see how all of a sudden there's a dip. Here, I'll draw it for you. There's a dip right here coming off the eastern seaboard, okay? And then the high pressure kind of gets squeezed. See it kind of right through there? And see how it's kind of bulging out right in there? That's your high pressure. That's what kept it away from Florida. But as that high pressure bulges a little bit to the west, that's also the key ingredient in determining how far west will Laura go before it makes its northerly turn. Because remember, we've been talking a lot about the high pressure. This should not be news to anyone that's been watching me. This high pressure, it's very obvious in the computer models. There it is. And I think the GFS American and the European have both done a good job with it. This is also why you see our storm down here, why it has followed along the southern periphery of that high pressure. Well, you see this right in here. You see that little gap? That's what we call a trough, an upper level low that's kind of sitting right in there. And that's where the storm wants to go to. Storms want to gravitate towards lower pressure. They're not going to go against a higher pressure. Higher pressure is a fence. It basically blocks. Whereas lower pressure is like, hey, come on, I'm welcoming you. So that's where the storm wants to go. Well, if we go forward in time, what I want you to notice is the high pressure, for example, tonight into tomorrow morning, it kind of nudges itself out here like this. In other words, now it's saying, nope, can't come here. You have to keep going in that direction. Okay. All right. Which is kind of expected, but how far will it go? Okay. Look at that. That's tomorrow at this time. Look at the western edge of that high. Oof, that's pretty far west. So now you're talking the high pressures all the way over here, and it's basically saying no. So it's almost to the point now where it's saying, no, you cannot go towards New Orleans. You're going to have to go west of there, which we already kind of thought it was going west of there, but you get my point. It's kind of going past the longitudinal line of no return, for lack of a better way to put it. Okay, now notice, this is like Wednesday evening. All of a sudden something's happening. The high pressure ridge appears to be backing off or eroding away, as sometimes we'll say as a meteorologist, and something different is happening. There is your upper low, right in there. Okay, so if this is accurate and if this is true, this gives you a good idea of why it goes west, 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 and then whoop, makes that turn. Now it's just a matter of exactly where is it going to make the turn. And the problem we have seen so many times over the years, hey, anybody that lives in Florida knows what I'm talking about. Remember Irma? We knew as a meteorologist a whole week out it was coming for Florida. We told everybody. But that little 20-mile turn difference can make a huge difference, because if it makes a turn, let me show you for example. All right, this is just a wind profile, one single model run, so don't take it verbatim. This is just an example. But you see that west-northwestward movement? See how it just keeps going and going and going and going and going, and then watch this. Whoop, whoop. See that? North turn. Boom. See, look at that. Last second. Boom. Straight north. So what it's going to do is it's going to go west, 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 with a little bit of northwest, of course. But then all of a sudden, the last second, it's going to go, whoop, due north. All right? The problem is, where is that due north turn going to be? Is it going to be there? Is it going to be there? Is it going to be there? Now, if you're sitting in Florida, you're probably thinking, what does it matter? Remember, though, when you were going through Irma in Florida, that little bit mattered a lot. Was it going to be Miami? Was it going to be Key West? And then depending on where it made that turn, then it determined on, well, is Tampa Bay going to get the worst of it? Is Orlando going to get the worst of it? Well, now you have to understand these people in Texas and Louisiana are dealing with the same thing that we were in Florida, which is Houston's right here, Galveston's right here, Beaumont's right here. Let's see, and right in here's Lake Charles, and right over here is Lafayette. So my point is, you've got a lot of population centers in that area. And if it turns here, you're talking Louisiana cities. If it turns here, you're talking Beaumont. If it turns here, oh goodness gracious, watch out, Galveston and Houston. And we all know Galveston and Houston have a history of big storms over the years. And I'm not talking just Harvey. I'm talking like going all the way back to the 1800s and early 1900s. One of the worst storms ever in the history of the United States. Well, this is the 1900 storm in Galveston. So that's why these types of storms put a lot of people on edge in Texas, and rightfully so. If you were to bring this type of storm back to Florida, it would put a lot of people on edge in Florida too. That is the GFS run. Let me show you the Euros. Let's see if it's come in yet. It's just starting to come in. So we're not there yet. And by the way, this just proves to you that I'm always looking at this stuff at the same time that I'm showing to you. It's not like I'm pre-rehearsing this or anything. So yeah, this data is just coming in. This is the 12Z data. And there you can see same west-northwestward movement, same strengthening too, by the way. That's something else I wanted you to notice. Remember when I was telling you that, yeah, all the strongest winds were on the east-northeast side? Both of these models, the GFS and the European, I think are doing a good job in showing, there it is right there, strongest winds east-northeast side. Let me take this out in time, though, and look what happens. All of a sudden, you start to notice, aha, it really starts to wrap up. See that? And all of a sudden, you start to see more of a symmetrical shape with strong winds all the way around it, all the way. Okay? And so that is why so many meteorologists and so many of us are sitting here going, oh, although we hope it doesn't strengthen too much, and there are some factors that might kind of pull back on it and keep it from getting too strong. The fact of the matter is you have to assume worst case scenario, which is it probably could become a major hurricane at this point. At this point, you kind of have to assume that. Now down the road, and by the way, I'm sitting here waiting on the latest from the European to come in, so I can't show you where its latest northerly turn is. I'll tell you what, here's what I will do though. I'll go back to the last model run, and I'll show you an example of how all computer models are different. Remember, we're just spitting a bunch of variables into them, and then it's running its physics and its equations, and then it's spitting out what it thinks. That's all it is, okay? So it's just guidance. It is not the end all, okay? But this was the last model run for the European, and let me show you, it does the same thing as far as west-northwest. See that? It's going west, 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 and then all of a sudden, watch the north turn. Whoop! There it is. The difference is, with the last European run, look how much further west it took it. Now, that might not seem like that big a deal. Again, with the GFS, it was like right here. With the European, it's like right here. That's a big difference, though, when you're talking about city versus city. So although it's not a big difference if you're out in the middle of the ocean, it's a big difference when you're on land. And so sure enough, that's a subtle difference, but that would be more like a Houston or Galveston to Beaumont hit. Okay, so see, that is a big difference. And by the way, those are pretty strong winds. Those look like Cat 2 winds right there. It is forecasted to become a major hurricane now, which again, like I said, you pretty much have to forecast that. You have to assume the worst, even though we hope it won't. We'll hope it stays a 2. There are some inhibiting factors. So if you're sitting there going, well, oh my goodness, it's just worst case scenario. Everything is just worse, worse, worse. Actually, it's not. Trust me when I say the last few years when we had the Dorians, the Irmas, the Marias, the Michaels, believe it or not, the ingredients were actually a little bit better at that time for these storms to really bomb out as Cat 5s. There are some things working against this. Number one, the cooler water that I just talked about. There's a little eddy of slightly cooler water. Okay, that's not a huge inhibitor, but it's something. There's a little bit of wind shear on the backside. The other thing I want to show you is some wind shear on the front side. Okay, not right now. There is no wind shear on the front side. See this? This is pretty much a perfect zone for it to strengthen, which again is why it's forecasted to strengthen, okay? But this area right here, this is why Marco died, and this is really strong wind shear. If that wind shear would just stay there, this storm would fall apart on its approach to Texas. Here's the problem. Watch what that wind shear does. It backs away. Okay, so it backs away, but it doesn't totally go away. So there's some hope here. There's a little bit of hope that, you see how there's still wind shear in here. You see it right in there? So it doesn't totally go away, but it backs off. So it backs off enough that really the strongest of wind shear is inland. It's not over the Gulf. So what we think, and what I think is probably going to happen is, yes, this storm is going to strengthen, it's going to intensify, and it will probably be at its peak intensity just before making landfall. And then as it makes landfall, what I think is going to happen is, you see that right there? Right there. I think the wind shear will start to work against it. I mean, literally the next hour that it comes ashore. Unfortunately, by that point, it's too late. It's already hit land. It's already doing destruction. It's already put a storm surge into the coast. But I do think that's going to happen. And you can see it even better a couple hours after landfall. See right in here? This is really strong wind shear. So my point here is, you're probably going to see a storm that's really, really strong going up against the coastline right there between Texas and Louisiana. And then it's probably going to weaken rather quick after making landfall. The other thing, too, is when you get a lot of wind shear from the southwest like this, you're most likely going to get the strongest part of the storm displaced on the eastern side. In other words, everything's going to tend to want to go to the eastern side. The strongest winds, and in general, that's already the case. We always say as a meteorologist, the front right or the front northeastern quadrant is the strongest. Well, in this particular case, it definitely is going to be the strongest. It already is right now, and it's going to stay that way all the way up to the coastline. And with this wind shear bumping up against it on the southwestern side, you will definitely have the strongest winds on the northeastern side of the storm. Why do I stress that so much? Because let's say the exact center misses Houston by only 10 miles to the east. That will save Houston by far from the worst. Let's say, though, then that does a really, really bad thing for Beaumont, Texas. You see my point? In other words, somebody's probably going to be on that northeastern side. Then let's say it goes over Beaumont, but that means the northeastern side is more like in Louisiana. You see my point? Like, those little subtle differences are going to matter. I think somebody will be on the northeastern side and get hit really hard, and then I think somebody's going to be on the western side and go, we didn't get to hit that hard. Plus, remember, storm surge is that way too. Storm surge, especially in the Gulf of Mexico, gets shoved up into the corners of the Gulf. And so whoever's on the northeastern side, it was like this in Katrina, it's been like this in Michael, it's been like this in every big hurricane. Northeastern side is going to get hammered, okay? And so that's going to be the problem with the storm, is the exact center. And look at that. On this particular model, the center just happens to be smack dab down the center of the Louisiana, Texas line. Here, let me take this back out. This is the 12Z GFS run. Look at that. I mean, oh my goodness. It could not be more smack dab center than the Texas-Louisiana line. All right, so with all that being said, I think at this point in time, you basically have to look at this as if you live anywhere between Houston and Lake Charles, those areas, essentially northeastern Texas coast to western Louisiana, you have to assume the worst. In other words, prepare for the worst, hope for the best, obviously. I'm an optimist. But you have to assume that you could be getting hit with a major hurricane by Wednesday time frame. All right. I think that was pretty much all I was going to cover. There is your latest forecast track. And notice, shows it right on the Texas-Louisiana line. Now, I will admit, the trend has been for some of these computer models to trend a little bit nudged west. Not a lot, but a little bit. Like, in other words, they were more like solidly in western Louisiana. Now they're more like solidly on the Louisiana-Texas line. I'm a huge fan, if you watch me over the years, of consensus ensemble forecasting, meaning take all your best computer models, put them together, and what's the consensus? Kind of like, what's the mean? I'm real big on that, because one thing I've learned in 20 years in this business is if you think that you can say, oh, well, look at what the UK did. Oh, well, look at the Euro did. And look at the GFS. Oh, well, look at the NAM. That doesn't do anybody any good. It's almost like just throwing darts. That doesn't do any good science. Good science is bring together your best ones and let's come to a consensus. It's not always going to be exactly right, but this at least gives you a good trend. So for example, this consensus yesterday was like right here. Today, it's right here. So if I'm in Houston, which by the way is right here, then I would be a little bit more concerned today, because all of a sudden it's like, oh wait, it did nudge a little bit closer. And by the way, if you're in Beaumont, which is located right about here, I'd be very concerned at this point. And that is a city right there on the southeastern Texas coastline. So those are some of the things that I'm watching right now. Here is the latest GFS ensemble run. It also nudged a little farther west. It's more like that southeastern Texas coastline instead of western Louisiana. Doesn't mean it's guaranteed to be right. I'm just showing you what I'm seeing. By the way, there is a little bit of a swell in the Gulf. I had that question yesterday. I briefly touched on it. It's not a big deal here in Florida. It will be a much bigger deal from now moving forward along the north central Gulf. Okay, so these waves are going to start to emanate, and there's going to be a bigger swell coming out from them. Back here, Tampa Bay and the western and the Gulf side of Florida, you'll notice a swell tonight and into tomorrow, but it won't be as big of a deal because, remember, the storm is moving away from Florida. In terms of heat potential, I wanted to show you, this is what I meant earlier when I said the really, really, really heat potential area. It's right here in the Caribbean, and yes, there is that little Gulf Stream area too. But the storm has already moved past that. See how there's a little bit of cooler air right through, or cooler water right through here? Okay, so now you see what I'm saying. All right, so there you go. That's the latest I've got. It's Tuesday afternoon. Hope you have a great day. And for all the Boston fans, I'm sure you're cussing at me right now for wearing a Lightning jersey, but sorry, hometown, got to go with Go Bolts. Let's hope they win tonight. All right, have a great day.